is your intro for lesson 19. And we want to just do a little bit of review. This is noble gas envy, and it's lesson 19, ions. Which group on the periodic table has the name noble gases? And that is the very last group where I have 8 valence electrons, and that's also the end of the period. Once I get to 8, then I restart. So noble gases are the gases on the far right side. And then why is the group in the last column called noble gases? This is actually a historic name. If you think about the nobility are supposed to be like impassionate and not reactive, that, anything happens and they're still like, really straight-faced without a lot of emotional response. And so that's how it originally got its name, was noble gases, after how kings and queens were supposed to behave without responding emotionally to anything. How many valence electrons do all of the noble gases have? Hopefully you remembered, they have 8 valence electrons in their outer shell. Okay, here's our chem catalyst. So chemists have found that metal atoms transfer electrons to non-metal atoms when they form compounds. So we want to examine the shell model showing how a lithium atom might transfer an electron to a fluorine atom. So lithium is in group 1, so how many electrons are in its outer shell? The answer is 1. Fluorine atoms are in group 7. How many electrons are in its outer shell? The answer is 7. And so what happens is that this lithium atom takes its outermost electron and it transfers to the shell here. So then we have 0 valence, 2 core, and then here we have 8 valence and 2 core. But as we've talked about, this 8 valence is an important idea. So what element does each atom resemble after the electron has transferred? So the lithium atom has 2 electrons, and the fluorine atom has 10 electrons altogether. 2 in the middle and then 8 in the outer shell. So as we look at the periodic table, if it was a neutral atom, what element would have 2 electrons, and what element would have 10 electrons? So we said that the number of electrons only equals the number of protons for atoms, and today we're going to learn about the situation for a particle when the number of electrons does not equal the number of protons, like we just saw. Because lithium, we have 3 protons, but we're saying that when it forms a compound, it's going to have 2 electrons. Fluorine, 9 protons, but when it forms a compound, 10 electrons. So that's what we're going to look at, is when the number of protons and electrons is not equal and how that happens. So we want to do a little bit of work at first. If I have a particle that has 5 protons and 4 electrons, what is the charge on the particle? And the charge is going to be +1, because this is +5, and then -4 is going to give me a total charge of +1. Let's do another one. Particle has 7 protons, 9 electrons. What is the charge on the particle? And that is going to be -2, because we have +7, and then -9 gives me -2. So that will be helpful today. Now, I don't want you to just copy, but we're going to look at the instructions, and I want you to summarize what you're going to do for steps 1 and 2. So the instructions are, in the upper left-hand corner, number the blank cards 1 through 20, then 31 through 38. And then you're going to shuffle the numbered cards and divide them evenly among your group members. So you're going to get, each group is going to get 28 index cards. What are you going to do? Okay. Now, each person is going to have a couple of cards, and you are going to complete those cards, and you're going to complete them according to step 3. So what the step says, the number on each card is the atomic number of an element. Create ion cards like the ones shown for each atomic number. And then this is the important part. What happens to the electrons for elements in group 1 to 3A? Read the instructions. Okay, elements in group 1A, 2A, and 3A lose electrons. And specifically, they're going to lose electrons. They're going to lose all of the electrons in their outer shell. So they're going to lose all of the electrons in their outer shell. Now, read the instructions. What happens to the electrons for elements in groups 5A to 7A? So here we have these. 5A to 7A gain electrons. How many are they going to gain? They're going to gain until they have 8 electrons in their valence shell. Okay, 8 electrons in their valence shell. So group 5, they're going to gain 3. Group 2, or group 6, they're going to gain 2. And group 7, they're going to gain 1 because 5 plus 3 is 8, 6 plus 2 is 8, 7 plus 1 is 8. So you're going to make these cards and talk about what they gain and then what the charge is. Okay. Elements in group 4A could gain or use electrons, so you want to use both cards to show either option, either gaining 4 or losing 4. So we're going to answer the question, how can you predict the number of electrons? All right, I have no idea why I have that slide. Okay, so go ahead and do the activity, and then we'll debrief.